We're going to talk about E, the big famous constant E. Okay, it's one of the famous mathematical constants, one of the most important. It goes along with pi and, I don't know, golden ratio and square root of 2. There are constants in maths that are the most important constants. And E is one of those constants. So E is an irrational number and it's equal to 2.718281828 something. The problem with E is it's not defined by geometry. Now pi is something that's defined by geometry, right? It's the ratio of a circle circumference and its diameter, and it's something the ancient Greeks knew about. But E is different. E is not based on a shape. It's not based on geometry. It's a mathematical constant that is related to growth and rate of change. But why is it related to growth and rate of change? So let's look at the original problem where E was first used. So we're going to go back to the 17th century, and this is Jacob Bernoulli, and he was interested in compound interest, so earning interest on your money. So imagine you've got £1 in the bank, and you have a very generous bank, and they're going to offer you 100% interest every year. Wow, thanks a lot, bank. So 100% interest, so it means after 1 year, you'll have £2. So you've earned £1 interest, and you've got your original pound. What if I offered you instead 50% interest every 6 months? Now, is that better or worse? Well, let's think about it. Okay, you're starting with £1, and then I'm going to offer you 50% interest every 6 months. So after 6 months, you now have £1.50. And then you wait another 6 months, and you're earning 50% interest on your total, which is another 75p. Then you add that on to what you had, so it's £2.25. Better. It's better. In fact, the more frequent your interest is, the better the result. What if I could do it continuous? What does that look like? That means if I take this formula here, 1 plus 1 over n to the n, I'm going to n tend to infinity. That would be continuous interest. Now what is that? What is that value? That's what Bernoulli wanted to know. He didn't work it out. He knew it was between 2 and 3. So 50 years later, Euler worked it out. Now Euler called this E. He didn't name it after himself, although it is now known as the Euler constant.
Why do you call it E then?
It was just a letter. Yeah, he might have used A, B, C, and D already for something else. Right, so you use the next one.
Would you have called it G if you discovered it?
I would not have called it G. No, I would have hoped somebody else would have called it G, and then I would have accepted that. Euler proved that this was irrational. He found a formula for E, a different formula, and it showed that it was irrational. I'll quickly show you that. He found that E was equal to 2 plus 1 over 1 plus 1 over 2 plus 1 over 1 plus 1 over 1 plus 1 over 4 plus 1 over, and this goes on forever. This is a fraction that goes on forever, but you can see it goes on forever because there's a pattern, and that pattern does hold. And if the fraction goes on forever, it means it's irrational. Okay, why is E a big deal? It's because E is the natural language of growth, and I'll show you why. Okay, let's draw a graph. Y equals ETX. So we're taking the powers of E. So here at 0, this would cross at 1. So if you took a point on this graph, the value at that point is e to the power x. And this is why it's important. The gradient of the curve at that point is e to the x. And the area under the curve is e to the x. And it's the only function that has that property. So it has the same value, gradient, and area at every point along the line. The reason this is important then, because it's unique in having this property as well, it becomes the natural language of calculus. And if you're interested in those things, you don't write it in terms of E, you get lots of nasty constants, and the maths is really messy. If you're trying to deliberately avoid using E, you're making it hard for yourself. It's the natural language of growth. And of course, E is famous for bringing together all the famous mathematical constants with this formula, Euler's formula, which is e to the I pi plus 1 equals 0. So there we have all the big mathematical constants, and they bring them all together in one formula, which is often voted as the most beautiful formula in mathematics. I've seen it so often that I'm kind of jaded to it. Don't put that in the video.